Okay, hello, Cloud Gurus. So far, we've looked at resources and roles and members, but now we need something to tie them all together. And that's where policies come in. A policy binds members to roles for some scope of resources. And in doing that, it answers the question, who can do what to which thing? So if you remember back to the resource hierarchy, you would find some place in that resource hierarchy to attach a policy, whether it's at the top level of the organization, some folder or subfolder within that, or maybe a specific project, or even a specific resource inside of that project. These are all places where you could attach a policy. And that attachment is how you identify the resources. The policy itself lists the roles and members, but it's only this attachment that defines which resources are to be affected. Now, an important thing to call out about policies is that they are allow only. If you attach a policy, you can only grant access. Attaching a policy can never deny someone access to a resource because it's always additive. The documentation calls out child policies cannot restrict access granted at a higher level, which means that if you give someone access at the organization level, that's it. They can always do that. This is why it can often make sense to put things in a folder even if you're not sure you're going to change things later. If you don't decide to change anything and every project winds up in that folder, then no harm done. It works just the same as if you had granted access at the organization level. But if in the future you find that you need some special case for a particular project, then you could always create a separate folder next to the original one and not have to change anything about the existing resources. So let's take a look at an example of a policy. Here's a policy that we might attach to some resource. Let's say that we attach it to a folder inside of an organization, and it has two bindings. The first binding says that Bob at example.com is going to be the owner for all of the projects that are underneath that folder. Now, if this were bound at a particular project level, then Bob would be the owner of just that project. And if it were bound at a particular resource, then Bob would have all of the privileges included in the owner role, but only for that resource. So attaching this policy to a folder that contains lots of projects gives Bob a lot of power, but attaching it to one tiny little resource that doesn't have much in it, well, that would be relatively much less power. The second binding in this policy grants the Compute Network Viewer role to a bunch of different members. Alice at example.com gets access, as do the admins at example.com, and every account in the example2.com domain gets access, and this App Engine service account also gets access, regardless of which project is using that service account. So let's take a look at a few more things about policies. Each resource can have exactly one policy attached to it. By default, resources generally have an empty policy attached to them. Now, in that one policy per resource, you can have a maximum of 1,500 member bindings. Now, the reason I point this out is not so that you'll memorize this, because you really don't need to. I say this because I want to call out that this is a ridiculously high maximum. If you are anywhere close to this number of bindings, you're doing it wrong. The answer is that you should use groups instead. I'm really not kidding here. Don't forget this. Groups are really important, both to your regular day-to-day usage and because of that, to your exam. But okay, enough about that. But that brings me to my next point, which is that you should use groups. Oh, did I mention that already? Yeah. Okay, a small thing to point out is that there is a limit of 250 group bindings in a policy, but that's still crazy high. You should never get to that either if you've got any sort of a sensible group structure. Okay, so if you attach a policy to a resource, it usually takes less than 60 seconds to apply those changes, whether you're granting or revoking access. But it might also be useful to know that the documentation says it may take up to 7 minutes for changes to fully propagate across the system. Again, this is more just something to be aware of, to realize that it's a thing, not something where you need to go and memorize these numbers. Okay, so I mentioned that there's one policy per resource. So how do you manage these policy bindings? Well, you could use the get IAM policy function, such as in gcloud, edit the JSON or YAML file that you get from it, because you can ask it for either, and then use set IAM policy to push that changed document back. But don't do this. I mean, you should know that you can, and there are some cases where this makes sense, such as if you're creating and initializing the resources, but in general, you would rather use add IAM policy binding and remove IAM policy binding instead. These two functions are atomic and granular, and they're better because it's much simpler and less work and less error prone to specify exactly which role and member you want to change. But this also will avoid any race conditions because you can do multiple of these things simultaneously and they won't conflict with each other. So let's imagine a scenario. Let's say that there are two people, or systems or whatever, that are trying to make changes at the same time to the same resource. And they both start by doing get IAM policy, and they get the same document. Then both of them will make their separate changes in that document. Maybe one person adds Bob as the administrator, and the other person adds Jane as the administrator. But when each of those two people will then set IAM policy their new complete changed document back, only one of them will win. This is a classic race condition. In the end, only one of the two new administrators will actually be an administrator. The other one will have been unintentionally removed as a part of the second one being applied. So let's think also about the data flow. If you do a get and set, you're shuttling way more data than you really need back and forth between the machine giving the command and GCP. And when it has gotten it, that machine will need to process that data, maybe even storing it locally as a part of that, and then push the entire document back, right? But with the add IAM policy binding and remove IAM policy binding, only the targeted instruction data needs to flow from the machine giving the command. That's it. It's definitely preferred. So an example command here would be gcloud beta compute instances add IAM policy binding to the resource myhappyvm and passing in the role roles/compute.instanceadmin and granting that access for the member user:me@example.com. This is how that command would look. Well, if you have any questions for me about policies, please let me know. If not, please join me in the next lecture where we'll finish off our IAM breakdown. Thank you.